So to go into our examples from chapter 1, we're asked to classify some real numbers. So our first example is -5. Is -5 a rational or irrational number? I guess we can start there. And we're going to say it's a rational number because we can express it as a fraction p over q, where p might be -5 and q could be 1, and so we're going to say it's rational. Then we can go one subset further in and ask ourselves, is it an integer? And the answer is yes, because it fits into this the values of -infinity to infinity. So yes, it's also an integer. But is it a whole number? No, because it's whole numbers start from 0 into infinity, and -5 is less than 0. Our second example is -1/3. So again, we start with the biggest subsets, rational or irrational. Well, just looking at it, it is a fraction already. P could be -1 and q could be 3. So yes, it is a number that can be expressed as p over q, so it's a rational number. And is it an integer? No, because it is not a simple number between -infinity to infinity. So we can stop there and say it is simply a rational number. Example number 3 is 0. Is it a rational or irrational number? We can say p equals 0 and q equals any number, like 3. So it can be expressed as p over q, so it is a rational number. Is it an integer? Yes, we see 0 here. Is it a whole number? Yes, whole numbers include 0. And is it a natural number? No, because natural numbers don't include 0. So it's a rational number, it's an integer, and it is a whole number. Example number 4 is the square root of 3. And we can say that it is not a rational number because it can't be defined as an integer over an integer. So we'll go ahead and call this irrational. And example number 5, I think, could be kind of tricky. It asks us if 1.4 repeating is a rational or irrational number. Just looking at it, we might be tempted to categorize it as an irrational number because it doesn't seem like a simple integer over an integer, but actually 13 over 9 is actually 1.4 repeating. So I think this example is in here to remind us that rational numbers can include numbers like, because we said for pi here, it's it has like an unending number of decimal values, but that's not what makes it irrational. What makes it irrational is the fact that it can't be expressed as an integer over an integer. 1.4 repeating does go on into infinity after the decimal, but it can be expressed as a fraction. Two integers, 13 over 9. So this is a rational number.